This is my camera setup for the smart doorbell. I've attached my camera to a piece of cardboard about the size of the Raspberry Pi camera and have it pointing straight down towards my front door on top of two boxes on my windowsill on our bay window. I use a rubber band to keep the camera in place to make sure that it just doesn't move while videotaping. This is my code for the smart doorbell masker. I'll run through it quickly, mostly skipping over things that we did in lecture, like the mask image. Most of this was done in lecture except for one part where instead of using a predefined points array, I can define the points in the function. So to do that, I have this create points function where it reads the points from a file and reads the number of corners from file and prints that out to a new array based on the points list, and it reshapes that to a 1 by 2 by whatever column. So to do this, I select the region of interest. I have this function here, selectROI, which you can define the number of corners and then also define the array. So if I take my Raspberry Pi and move it to some other place, I can have a newly defined mask and a newly defined array. That's so much easier than redoing the ROI every time. So that works by Python 3 selectROI, and it'll take the picture. And when the picture is taken, I'll say 6 corners, and it'll pick. I can just go through 1, 2, 3, 4, 5, 6. So I have 6 corners, and the array is created. So then, when I run my smart doorbell function, the smart doorbell function then uses that new array, and that is my new mask. And I can use that wherever, and it'll be very easy to switch around. So then, a lot of the rest of this was basically what we did in the lecture series, where you take a picture, you will write those pictures to the array. I use the 500 millisecond change rather than a second because I found that to be better for me. You define the mask one and gray one using the mask images. You compare the gray masked images against each other to find any dissimilarities. I found the threshold of 50 that we initially used was fine for myself. I set if the detector total is greater than 300,000. I use 300,000 here because sometimes if there's like shifting winds and the tree shadows move around, there could be changes in the detector and it will get up to roughly maybe 200,000 at max. But in this case, 300,000 usually will only occur if there's something or someone actually in front of the door. So here we start recording the video, we say something was detected, and then we write the gray 1, gray 2 and things to file, we upload the video to Dropbox, we email the gray 1, gray 2, test 0, test 1, 2, 1, mask 1 and mask 2 videos all to myself at my own personal email, and then we text myself using the Twilio software to say that something was detected at this time, the time being whenever the thing was detected. If nothing else, we print nothing detected yet. So overall, this is mostly what we did in lecture, except for the defining my own points array, which took some effort and was pretty challenging and gave it a little more depth than just doing what was in lecture. To show my Start Doorbell program working, I will run the code on my Raspberry Pi remotely and then go outside and trip the feature. So I'll speed up the actual code in terminal so that we can get to the point where it detects me. And as I'm walking outside, it detects my movement and it says smart doorbell detected, and you can see it starts recording a video and you can see the video here on the screen. After the video is completed recording, the smart doorbell will then create an email and send me pictures of the test 0, test 1, gray 2, mask 1, and mask 2 as discussed earlier in the code, and it'll also send me a text through Twilio to my phone saying that the smart doorbell detected something at the door as a notification that something was at the door. Thank you for watching this video. It was a fun experience going through all these processes and figuring out how to create this setup.